the problem.
Hi. Okay, so we draw this circle with a diameter of 1. Now, if we draw a square around it, all the sides of the square will also be 1, so the perimeter of the square is 4. Okay, you still with me? So some people say you can redraw the square like this so it touches the circle and it still has the same perimeter. Okay, cool. So now they're saying to do that again and again until you're left with a square that looks like a circle. And the perimeter is still 4, so the perimeter of the circle is 4. So I guess the whole pi thing is garbage then. Yeah, I don't really know what the answer is. Yeah, I'm just kidding. I know the answer to this.
The answer.
Okay, so let's just look at the corner of this circle, okay? We can clearly see that the square is not touching the circle. So the circle's perimeter is obviously not 1. So now, when we fold the square over, it appears to be getting closer to the circle. All right, so let's do it again. All the squares are almost getting close to the circle, but hold on, look. If we move all the pieces up, we're back with what we started with. This is not how the circle is. In fact, this is just a little bit of trivia here. This is pretty close to what we call a fractal. In fact, it might be a fractal, I don't know. Doing these little folds does nothing to get closer to the perimeter of the circle, even if we do it 1,000,000 times. If we zoom up enough, we'll always have these little guys always sticking out, which means it'll never be the actual perimeter of the circle. And then if we put these little pieces together, we're left with what we started out with. So yeah, pi still equals pi. These guys know what they're talking about.
Knowledge.